Welcome to the lab portion on the OSPF timer lesson. Specifically, the timers we're looking at are the hello interval and the router dead interval. This is a topology we'll be using such that it is no real reason to go too deep into this. There's a single serial connection between R1 and R2. It's going to be running the 10.1.12.0/24 subnet on that. I'll also have loopback interfaces active on R1 and R2. It will be the quad address of the router number. So for router 1 to be 1.1.1.1.1/32. Let's jump on to the CLI. Okay, so here we are on the CLI. Let's go ahead and take a look at what we have for interfaces. You can see we just have the two interfaces, and if I do a ping to 10.1.12.2, which is R2, it is successful. If I do a show IP OSPF neighbors, you can see that we do have a neighbor adjacency. It is in the full state. This is a point-to-point, so you won't see a BDR or DR election on there. So now let's go ahead and take a look at the timer. So if I do a show run int S0/0, I'll show you that nothing is up my sleeve. There's no OSPF configuration on here. So now if I do a show IP OSPF interfaces, and I specify 00/0 and I hit enter, we'll get a ton of good detail out of here. The main part that we're looking at today is we want to take a look and show you that this is the OSPF neighbor type. It's a point-to-point neighbor type. So if we remember from the theory session, we should know that the hello interval is going to be 10 seconds and then the dead interval is automatically 4 times that, so it's going to be 40 seconds. And we can see that right here in the very next line. We can see that the hello interval is 10 seconds. These values are in seconds. The dead interval is 40 seconds, and then because the wait interval is fed from the value of the dead interval, it is 40 seconds. So since we do have an OSPF neighbor relationship, if we go ahead and take this command and pop over to R2 and feed this in, we should see the same thing, and we do. So we have the same values on this side because by default it's going to make this a point-to-point network type. So let's have a little bit of fun here. Well, fun being a little bit subjective in this case. Let's go to configuration mode. Let's go under the interface because that's where we are going to be making our changes to the timers. Also under the interfaces where you can make changes to the OSPF network type. So if I type IP OSPF, and that's going to be the keywords for the vast majority of commands when you're under the interface. And you can see here there's a number of different commands. What we're looking at today is we're going to look at the hello interval and then the dead interval. And right now, I'm also going to take a look real quick at the network, which you can see here means network type. So what I'm going to do is I'm going to change it from the default network, which right now is point-to-point. And let's pick a different one here. Let's try point-to-multipoint for the hell of it. Now, when we do this, we should see our neighbor relationship go down. And it did go down because what we've done now is we've mismatched the types on either side of this. But what we want to do is we want to take a look at this OSPF interface command. You see here it did change it from point-to-point to point-to-multipoint. And the reason I chose this is because this is one of the network types that has a default interval of 30 seconds for the hello timers. And then if you can multiply by 4, you can figure out what the default dead interval is. It's 120 seconds. And as I've stated before, this wait timer is fed from here. So you can see that when you change the network type, depending on what you change it from, there's really 2 values it can be for the hellos. It can be either 10 seconds or 30 seconds. So if you change it in the case of point-to-point, which is a 10-second hello, to point-to-multipoint, which is a 30-second hello, it will change those timers on its own. And if you don't change the other side, you will lose your neighbor relationship, which is exactly what happened here. So we do a show IP OSPF neighbors. We should see, yeah, we don't have a neighbor. So let's go back in and just up arrow a couple times, and then I will reverse out that command. So now if I do my show IP OSPF interface, I do see that I have point-to-point. I see that my hello interval has been restored. And if I do a show IP OSPF neighbor, I can see that we are back to having a neighbor relationship with router 2. Okay, so that's one way to change the timers, but it's not the recommended method. It's not what we're really looking at here today. So let's go on R1 once again, go into configuration mode. We will go under interface 00/0. And then if we do IP OSPF, like I said, we can see here that we can change the dead interval or the hello interval right here. So let's go ahead and do that first. Let's go ahead and do the hello interval, and I'll invoke Cisco iOS help with the question mark. And you can see here we could set it from 1 to 65,535 seconds. By the way, that upper limit, that 65,000 number, that works out to about 45.5 days between hellos. So if you have an extremely stable network, you can go ahead and set that. I would not recommend that. So what we're going to do here is we're going to change it from the default of 10 seconds to let's make it 5 just for the hell of it. So we're cutting the hello interval in half. Now, if you remember back to the theory lesson, what's going to happen here? There's going to be two important things that happen when we do this. So right now we have a neighbor relationship with R2. Our hello interval is currently 10 seconds. Our dead interval is currently 40 seconds. So when we change this, two important things are going to happen. First of all, well, it's going to change the hello interval, and by default, Cisco will change your dead interval to 4 times that. So we should see the hello interval go to 5 seconds and the dead interval go to 20 seconds. Second thing that's going to happen is that because we're only changing this on one side, we're going to have a timer mismatch. When you have a timer mismatch with the hello and dead intervals, that is going to break your OSPF neighbor relationship. So we should see the neighbor go down. So let's hit enter here. I'll break out of configuration mode and I'll up arrow to hit show IP OSPF interface command. And you can see here, we're still point to point. We didn't change that, but now our hello interval is 5 seconds. Our dead interval is 20 seconds, which using my amazing American math skills is 4 times 5. So now we should be seeing this neighbor relationship go down, and you can see here this dead timer, that's going to decrement. So if I catch it here, we got it right at 0. It's going to get set to normally 40, but in this case, since we changed, it's going to be set to 20 seconds. So what it's going to do is it's going to count down from 20 to 0. And if it does not receive a hello packet within that amount of time, then it's going to go ahead and expire that dead timer. And when that dead timer expires, you will lose your neighbor relationship and you will get a handy dandy message that says dead timer expired. One little bit I should clear up there. I said that it has to receive a hello packet within that interval. That's true. It also has to be one that it agrees with all the parameters. So R2 is still sending hello packets every 10 seconds. It's just that when we receive one and it would fall within the 20-second dead interval, we're not accepting it because we don't agree on the parameters. And what we're going to do here now is we're going to do exactly what we just did, but this time we're going to have a debug running so we could take a look in the background what's going on. Actually, let's do that first. Let's go ahead and clear the log. And now I'm going to debug IP OSPF, and you have a bunch of different options here. The one we're going to look at is just the hellos, if I can spell it right. I'll issue my standard caveat: do not do debugs on production devices unless you are absolutely sure that you're not going to run up the CPU or break your device. I wouldn't do it except in extreme troubleshooting instances, and I wouldn't do it without a proper change control. Anyways, you've been warned. So now we have the IP OSPF Hello debugging on, and within a few seconds here we should see the hellos being exchanged. So we're sending a hello. Okay, that's all we need for right now. You all is undebug all. So let's take a look at this output. So we sent a hello. We're going to send these every 5 seconds now. You can see here that was at 46. This is at 50. So it's about every 5 seconds. It's not exact. Close enough for government work. So here's what I was looking for. So now we've received a hello from 2.2.2.2, which is router 2, and it tells you the area that's coming in on. It gives you a lot of good information. It shows you the interface it's coming in on. It shows you the IP address of the interface that sent it. So while this 2.2.2.2 is the router ID of R2, this is the actual interface IP that it was sent out on from R2. Anywho, so we now see the important part here, which is the mismatched hello parameters. And right here we can see dead, then you got this R and this C, and then hello. So this is our hello messages, and the R means received and the C means configured. So we changed our hello interval to 5 seconds. So that is our configured value of 5 seconds. R2 is still sending them out every 10 seconds. So that's where the mismatch is occurring. It's also occurring in the dead timer because you have a received value of 40 seconds and then a configured value of 20 seconds. So this neighbor relationship will not be established until we match these timers. So we can either set them on this side back to the default values of 10 and 40 seconds, or we can go to R2 and match them with the new timers that we've configured of 5 seconds and 20 seconds. Okay, in the interest of saving a little bit of time and sparing you the boredom of watching me type, I've gone back under interface 00/0 and I have reset the IP OSPF Hello interval to the default. So it's now 10 seconds rather than the 5 seconds that we had changed it to. And we can show that our neighbor relationship has been reestablished. If I do a show IP OSPF neighbor, see that it's back up and it is in the full state. So now I told you could see the dead time here. This is a timer that counts down and it's replenished every time you receive a hello. So if I up arrow here, all right, it's at 34 seconds, 32, 31. It should never go to anything less than 30. So every 10 seconds it should be replenished and go back up to 40. So that's how you could tell if your hellos are being exchanged. You can also check the hello exchange if you do a do show IP OSPF interface 00/0. This bit right here, hello do in 5 seconds. What that's showing is when we're going to send out our next hello. So that should go down to 10. Let me make this a lot easier here. All right, so it's in 2 seconds and 0 seconds, and now it goes back up to 10. My fingers aren't fast enough to catch it, so it says, okay, I'm going to send one in 2 seconds. I'm going to send one in, well, 0 seconds, so I'm sending one rather quickly here. And then once you send one, this timer goes back up to 10 seconds. One thing that's kind of interesting, I don't know that it'll become a gotcha in the real world, but if we go ahead and we change our hello timer to, let's say 1 second. So we're sending one out every 1 second. And then after 4 seconds, the dead interval should expire and we should have a neighbor down state. So we should only see this up for 4 more seconds after we implement this. So if I go ahead and hit enter, what I want you to see here is the OSPF neighbor. See here how the timer, the dead timer, is still decrementing down from 40. So we've changed it. So if I do a show IP OSPF int series 0/0, and I'm just going to take a look at the timers. I'm doing this fast enough. So we have a hello interval of 1 second and a dead interval of 4 seconds. And it's going to time out now, but you can see it took the full, whatever, 40 seconds for this to go down. So even though the hello interval changes right away, the dead interval, for whatever reason, did not change from 40 seconds down to 4 seconds. Not really a big deal if you're doing this in production. It might throw you off a little bit if you're just labbing around like, why did this take 40 seconds to go down instead of 4 seconds? Because the reason it's going down is we have mismatches on our hello packets between the devices. Anywho, just wanted to show you that. Okay, leaving the timers as they are, as the defaults of 10 for the hello and 40 for the dead interval. Let's go ahead and clear the log on R1, and I'm going to go ahead and do that debug. Spell correctly. Actually, I'm not going to hit enter yet. I'm going to go over on R2 and configure this, and what I'm going to do is actually just remove the entire OSPF routing process. That's going to break OSPF. It's going to remove OSPF on R2, and so obviously we're not going to be sending out OSPF hellos anymore. So what I want to do is on R1, I want to debug this, and after 40 seconds this should go down because it's not receiving any hellos. So let's go ahead and turn on debugging here, pop back over here and hit enter. So now I'll break out of configuration mode, and what I should see is I should see me sending hellos every 10 seconds and then not receiving anything. So after 40 seconds, which should correlate pretty well with the 4 hellos that I'm sending, we should see this drop. So I'm actually going to pause right now to spare you watching this ticking clock. And there we go. I'll turn off debugging. And let's take a look at the log because it's easier to read that way. So you can see here 1, 2, 3, 4. We sent 4 hello packets. We're not getting anything back because OSPF has been disabled on R2. And then after the 4th packet, which correlates pretty well with 40 seconds, you can see here, started at 47 seconds and ended at 18. So that's close enough for government work. We can see that the OSPF neighbor relationship went down. So that's a normal operation, is that it's going to let you miss 4 hello packets from your neighbor before it drops the OSPF neighbor relationship. Now, let's say that we want to change that. Let's say that instead of waiting for 4 missed hellos, we want to only wait for 2. So the way that we can do that is by changing the dead interval, and we'll take a look at that next. Okay, I paused and I did a couple of changes. What I did was I re-enabled OSPF on R2, and then I went in and made sure that our neighbor relationship was back up. So we do have a neighbor relationship with R2. So now let's go ahead and here I'll show you that it is under the interface. Go under 0/0. What we'll do to change the hello timer is we'll do IP OSPF. Remember, that's how you get to all these secret OSPF commands under the interface. Take a look at this. What we want is the dead interval. And you can see here, it gives us the same values. You can set this from 1 second, which I would not recommend, all the way up to the 45.5 days, which I also would not recommend. There is this keyword minimal that will be discussed in another lesson. That is to enable a feature called OSPF fast hellos. Basically, it sets the dead timer to 1 second and allows you to send sub-second hellos. It's a pretty interesting feature. I have a separate lesson on that. What we're looking at right now is we want to change the dead interval. Okay, so we had said that we want only 2 missed hellos. So our current OSPF hello interval is 10 seconds. So if we set this to 20 seconds, that means that we're going to send out hellos every 10 seconds, but after 20 seconds, if we don't receive one, we're going to go ahead and shut down the neighbor relationship rather than waiting the 40 seconds that we would have before. So what I'm actually going to do before I do this is I'm going to clear the log. I'm going to do debug IP OSPF hello, and then IP OS dead 20, and then break out. And again, I will pause. Turn off debugging. This had that same issue that we saw earlier. So if we do a show IP OSPF interface 0/0/0, and I just want to take a look at the timers. See here that we do have a hello interval of 10 seconds and a dead interval of 20 seconds. But we ran into the same thing that I showed you earlier, because if we do a show log, at this point we're only going to wait 20 seconds to take down this neighbor relationship, which should be equivalent to missing 2 hello packets. And we're getting hello packets from R2. They're just mismatches, you can see up here. We'll take a look at this on the log. It's a little clearer there. Don't have to do a do here, just show a log. So we're receiving hello packets from R2, and we've got that dreaded mismatched hello parameters. You can see here that the hellos actually aren't mismatched because we have a received value of 10 seconds. That's what R2 is saying it would like to use, and we have 10 seconds configured. So you can see here it was the dead interval that actually broke it this time, because we're receiving a dead interval of 40 seconds, but we're configured for 20 seconds. So normally we would miss 2 packets. So it should have been like right around here that we saw this go down. But if you look here, so I'm just doing basically a grep that says I just want any entry that has RCV, which is receive, and the expire, which is the expired. That last guy on the bottom was after the neighborly relationship had already expired. I just didn't type undebug all quite fast enough. So here we see that we received 4 hellos before we dropped this relationship. And if we look at the time here, it took about 30 seconds. Anyways, it was more than the 20 seconds. So we kind of ran into that same bug or glitch or whatever you want to call it, where even though we set dead timer to 20 seconds, it was still using the existing timer of 40 seconds before it timed this out. So we could do this again here, and what I'll do is I will go on R2, configure 00/0 AP OSPF dead, and make it 20, and we should see this come back up. I might pause if it doesn't come up soon. There it goes. So now if I do a show IP OSPF neighbor, you can see here that we do have a full state because we are now matching on both parameters, the hello and the dead interval. So we can see that the dead interval is counting down from 20. So we saw it count down to 10 here, gets another hello, and it replenishes it back to 20. Okay, so let's go ahead and we'll just clear the log on R1, and then we will set up our debug. IP OSPF hello. Well, I didn't hit enter yet, so I'm not actually debugging yet. What I'm going to do here is I am actually going to blow away the OSPF process. So we'll disable OSPF on R2. That will stop the sending of hellos. And let's go ahead and hit debug over here and take this away, and I will pause. Okay, so the neighbor relationship has dropped. I turned off the debugging. So now if we do a show log on R1, you can see here that we sent 3 hellos. You know, the timing was maybe slightly off, but started at 4 seconds and ended about 20 seconds later. So our 20-second dead interval actually worked this time. So after 20 seconds, this guy dropped, which is equivalent to about 2. You say about because they're not exactly 10 seconds apart, and I might have turned on the debugging, just caught this guy before the other side had gone down. So if you get a question on an exam that says a dead interval is set to 20 seconds, hello interval is set to 10 seconds, how many hellos can be missed before the neighbor relationship is declared down? 2 is your best answer. I would look at the answers. If there's 2, 5, 1, 6, something like that, then 2 is definitely your answer. If there's 2 and 3, then you might want to quibble, but I would still say 2 is your best answer for that. Anywho, let's move on. Okay, and as I mentioned in the theory section of this lab, when you change the dead timer, do show. Okay, so when you change this, you do want to send it to a multiple of the hello timer, which is what we did here. We set it to 20 seconds. Because what you don't want to do is, say, set this to 15 seconds. Because now if you miss 1 hello, you're going to lose your adjacency. Because what's going to happen is it's going to say, okay, I've got 15 seconds on the clock, and I'm waiting for a hello. So 5 seconds into that, you're expecting your hello from R2. It doesn't come. Something happened with R2, whatever, the packet didn't get out for whatever reason. That will occasionally happen, even on a network that's working normally. Occasionally packets just don't make it for whatever reason. That's why Cisco by default lets you miss up to 4 packets. So anyways, it's like, oh, okay, well, I screwed that one up, that's fine. In another 10 seconds I'll send another packet, will be golden. Well, at that point, the dead timer is going to expire before that next hello comes in. So it really makes no sense to set this to a value that's not a multiple of the hello interval. And that's why I think it's actually a good thing that Cisco by default sets it to a value that is 4 times that of the hello interval. What I will show you here is that you can go ahead and set this. You can set it to 12, say. typing skill. And here we set it to 12. Really doesn't make much sense. The other thing you can do, which is really odd, is that you could set this to a value lower than the hello interval, and it doesn't catch that. That's really bad juju, because you will never establish an adjacency here, because it's going to give you 5 seconds. I shouldn't say never. It depends when this guy fires off, but if you do have one, it's going to be extremely short-lived. The other thing you don't want to do is even set this to the same interval, which is what I'm going to show you next. Okay, and what I did was on both sides, I set the hello and the dead interval to 1 second just to speed up the process. And if we go over to R1, we can see the same thing here. And you can see what's happening here. The neighbor relationship is coming up and it's going down. If we do a do show log, just take a look at the last bit here. So you're saying, okay, I've got a hello interval of 1 second, so I'm going to send out hello packets every second. I've got a dead interval of the same amount, which is 1 second. So after 1 second, if it does not receive a hello packet, it will drop the relationship. And you can actually keep this up if your timing is right. If you're getting one, now we're going to fractions a second. After 500 milliseconds, you receive a hello packet from R2. That'll keep it up because you would still have, 500 milliseconds. I don't know how exact the clock comes in here, but more often than not, you're going to end up with something like this where it's coming up for a brief amount of time, then dropping, then coming up and dropping, and coming up and dropping. So that's the lesson to learn here is do not set those to the same interval. Don't set the hello timer to the same interval in seconds as you set the dead timer, because we're doing this with 1 second, so we're seeing a lot of this. If this was 40 seconds, this would happen quite a bit, but it might not be every interval, and it would just seem to be sporadic. So don't do that. This is also a great troubleshooting question for, say, the new T-Shoot exam or on the CCIE exam, where they give you a network where it's set up this way, and generally they're not going to have it at 1 second. They're going to have it at 10 seconds or 40 seconds, whatever the defaults are. And then you would get something like saying, hey, company X has been having problems with their OSPF going up and down. What's the problem? And a lot of times, if you don't know to look under the interfaces for the hello interval or the dead interval, or you don't know how to use that show IP OSPF interface command to look at the timers, you would be looking at a whole ton of other stuff before you looked at that. You'd be looking at the circuit, trying to determine if the packets are going across there, if you're losing packets. I mean, this could happen in the real world too, where you're not thinking about these timers because they're matching. It's just that the timers are off by enough where it's coming up and going down. So that's going to wrap up the lab portion of this lesson on the OSPF timers. The big takeaways are that different default network types, OSPF network types, are going to assign different defaults for these timers. It's either going to be 10 seconds or 30 seconds for the hello interval. And if you know the default hello interval, you're going to know the default dead interval because it will be 4 times that. If you change the hello interval, by default, Cisco iOS will make your dead interval automatically 4 times that. So if you change the hello interval to 2 seconds, your dead interval will automatically be changed to 8 seconds. That does not work the same way when you change the dead interval. If you change the dead interval, it will not affect the currently configured OSPF hello interval. So if your hello interval is 10 seconds and your dead interval is 40 seconds and you change that dead interval to 20 seconds, it will not go ahead and change the hello interval to 5 seconds to keep that 4 missed packet rule. A couple other things. It doesn't make much sense to set the dead interval to a value that is not a multiple of the hello interval, because basically all the dead interval is doing is allowing you a number of missed hello packets, so you might as well keep it at a multiple. The other thing, and what we just saw here, and we can see still continuing in the background, is that you do not want to set the hello interval and the dead interval to the same amount, because you will end up with sporadic up-down states with your OSPF neighbors. Thanks once again for joining me in the Packet Lab, and as always, I hope this helps you on your route to becoming a network